Welcome back again to my channel. Thank you so much for tuning in, and today we want to automate a project, an hands-on project that we did some time ago that I released on the channel. We want to automate that same project today using Terraform and GitLab CI/CD. Now, some time ago, I did a live where I demonstrated how you can deploy a PHP application on AWS with ElasticBeanstalk. Now, we used ElasticBeanstalk, the credential that was generated by the RDS, which is the username, the password, the database credential, was actually stored inside of AWS parameter store. And the application that we hosted, which is the PHP code, of course, it's a simple contact form that would allow people to maybe fill some information and then upload a document. And that document is expected to be stored on our S3 bucket. Now, we did all of that, project on the console, and I believe that I did a walkthrough that showed you how to create your ElasticBeanstalk, how to create your parameter store to store your credentials, how to set up your RDS, how to create your bucket, and all of that. But in today's video, we want to automate all of the process. We want to use Terraform, and we want to deploy also through the GitLab CICD. That is what we're going to be doing in today's video. All right, so if you're excited about it, let's get right into today's session, and then I'll walk you through exactly the Terraform code and all the other things as regards how to deploy these automatically with Terraform and GitLab CI/CD. Let's get started. Now, today we want to automate the project that I just showed us, and we are going to be doing that through Terraform and GitLab CI/CD. Now, here we have also adopted a modular approach like we did for the last video that I uploaded on this channel. We have divided every of our configuration, the ElasticBeanstalk configuration, the IAM configuration, the network, the database, S3, even security group. We have divided everything into different modules. So we have a module for ElasticBeanstalk, like you can see here. We have a module for IAM, we have a module for the VPC, subnet, and all of that. We have a module for database, RDS, we have a module for S3, and then we have a module for the security group configuration. And inside of here also I have my GitLab CI file, which is the pipeline file that would help us to automate all of these things. And then here in the root module, I have my backend.tf, which basically defines the provider configuration. The provider configuration, the backend configuration, like the S3 bucket that I want to use, the region, the DynamoDB table that I want to use to lock my state when I'm running any kind of Terraform apply configuration, and then the provider specifying the version of the provider and all. And then here I have my main.tf, which is where I have all of the modules being called. All the chat modules are called in the main.tf that I have in the root module. And of course, you have all of the different modules, the S3, the network, the RDS, the IAM, the ElasticBeanstalk module itself, the security, module, and all of that. And then of course there are some outputs that we need to generate as well, the bucket name, the deployment bucket, the RDS. All of these are outputs that we need to print out on pipeline console. And then I have my Terraform.tf, which is where some values have been assigned to certain variables that we have used. And then in the root folder also you have your variables.tf. Now, just to quickly recap before I walk you through all of the configurations that we have, is that in the last video I remember that I mentioned that now your variables.tf that you have in the root module and the Terraform.tf will only contain variables that you have used in other chart modules, and then your TFS will only contain the variables that you want to assign values to, because in the chart module there are variables that you're going to use that are going to source their own values from other modules, which means some other modules are going to generate they're going to generate output for us, and then these other modules will basically leverage that output as their own input. All right, so that means your variable.tf in the root directory is not going to contain all of the variables that you have in the child module, right? The variables that are going to be there are the ones that you want to assign values to, all right, from your TF vars. Okay, which means those variables are not sourcing their values, all right, from any, all right, module. Okay, they are basically getting their values. We are supplying those values. Is that okay? Now here we have about 1, 2, 3, 4, 5, 6, all right, modules. And of course, we have the module for ElasticBeanstalk, which is the platform as a service environment that is going to host our application code. And here is the code that we want to run, all right, on ElasticBeanstalk. It's a PHP simple, all right, contact form application. All right. Now, the only thing that we are doing today, like I mentioned earlier, is that we are automating all of the processes. I mean, we've already done this project already on the console. And then, of course, we have a video on that on the channel. But now we want to take it to another level where we automate the whole process. We don't want to create anything on the console. We want to basically manage everything through the pipeline and, of course, through Terraform. Okay. Now here you have the ElasticBeanstalk, and I remember telling us in the last video that every module that you create, when you're using a modular approach in Terraform, every module you create must have a main.tf, must have an output.tf, and of course a variables.tf file. Those three things are very, very important in every module that you create. Now there can be other TF files inside of your child module folder, but those three are very important. The main.tf, the outputs.tf, and the variables.tf, these three, all right, files are very, very important that you have, all right, them. Now let's take a look at the ElasticBeanstalk. So here we have the main.tf. Now, inside of the main.tf, all right, we have definitions, all right, for the ElasticBeanstalk. Now, remember, when you're dealing with an ElasticBeanstalk, now, when you want to create an ElasticBeanstalk on the console, the first thing you do is that you create an application, and then you create what you call an environment, all right, on the console. Okay, now all of the things that we have here, like I mentioned to us in the last video, you can actually get them on the Terraform documentation page. Okay, you can go there on the Terraform documentation and then you can see all the resources that you can create as it relates to ElasticBeanstalk or any other service or resource you want to create on AWS. Is that okay? So here we have the app that we want to create. So we give the app a name, and of course we are following best practices. So we are going to use variables for most of the things. All right. So we have the app name, we have the app description. All right. All using variables. And then our environment, we have to define our environment because, I mean, it is your environment that is where you define, all right, the platform that your code wants to run on. In my own case, my code is going to run on a PHP 8.3 stack, all right, running on Amazon Linux 2023, all right, and the PHP version that I'm using is also the version 8.3. Is that okay? So all of that is what I have to define as part of my environment. So here we have the environment definition, like you can see from here, AWS ElasticBeanstalk environment, and then we give it a logical name env, and then the name of the environment, the application referencing this application that we have created earlier, and then the solution stack. All right, which is basically telling, all right, ElasticBeanstalk that this is the stack that we want to use, right? Because there are a lot of stack that we can use. And if you look at my variables.tf right here, all right, the stack was basically specified. I mean, it's a variable, but of course we give the default value. So here we are using the 64-bit Amazon Linux 2023, the 4.42 version, which is running 8.3. All right, that is what we are using. I mean, the latest stack in that category. All right. So now if you click on main, of course, you have some other settings that you have to specify. Remember, your ElasticBeanstalk, all right, I mean, you have to specify whether you want to load balance your traffic, the port number, the process, all those kind of things. Everything is defined by what you call the settings attributes. All right, the settings attribute is where you define all of those other things. So here we have under the environment, you can see that the settings is actually under the environment resource. Okay, it is not outside of the environment resource, and it is not under, all right, the application resource. Okay, because all of the other settings that you're going to apply going forward has to do with what your environment. Okay, so under the environment resource, then we now define the settings that we want to apply to our ElasticBeanstalk environment. Okay, so in this case, we are basically telling ElasticBeanstalk that we are going to be using the load balancer as, all right, our load balancer type. And of course, the type of load balancer is going to be an application load balancer. And the reason we are explicit about this is because if you do not specify the type and the value of the load balancer, it is going to just go with a classic load balancer by default. That's what it's going to go with. All right. Now, the next settings basically is defining what you call the process in ElasticBeanstalk. Now, I will advise that you go watch that video, all right, that we did earlier, which I showed us, when we started, and basically understand how we did everything on the console, so that all of these things or some of these things can make more sense, all right, to us. Okay. So here we have the settings, and then of course we're defining the process, and here is basically the process is like you setting up the protocol you want to leverage and how the application will be accessed using the load balancer. All right, and of course it's a web application because the PHP application, so it's going to be accessed on port 80, and the protocol is going to be HTTP. So that is also part of the settings. Now, another thing that is part of the setting that we are very conscious about is the security. All right, I mean, monitoring is very important. I mean, it can help us to identify some security issues with, all right, our environment. So here we are also enabling, all right, CloudWatch logs. Basically, our ElasticBeanstalk environment should stream all its logs, all right, to CloudWatch. So from there we can see what is happening. We can see all the GET requests, and then if there's any error in terms of the infrastructure, the environment, we can also fetch that, all right, from the CloudWatch, all right, logs. And then we continue with all the settings and all the namespaces and all those kind of things. And then, of course, when you are creating an ElasticBeanstalk, you have to define the instance, all right, that you want to use. Now, AWS no longer supports the launch configuration. All right, they support what you call the launch template now. The launch configuration has been deprecated, but when I checked on the let me check that. When I checked on the Terraform documentation, all right, so let's go to Terraform, all right, ElasticBeanstalk, all right, AWS ElasticBeanstalk. All right, when I checked that AWS ElasticBeanstalk, resource, I didn't find, okay, the launch template being mentioned. What I saw there was actually, all right, the launch configuration. Okay, if you look at what you have here, what you have on the let's take a look. All right, so we have some, of course, I can see template here, but I've not really explored that, right? The configuration template to use in deployment. But what I saw also was that you can still use the launch configuration as well. So under the attribute reference, you can see here that the launch configuration is still, all right, being mentioned. Okay, but I believe that perhaps they have switched to the template, which is this one, the template name, all right, but that launch configuration is still going to work, all right, for what we want to do, all right, and that is why we have the launch configuration right here. Now, when you're using the launch configuration or even a launch template, of course, you want to define some things, and you want your EC2 instances to assume a role, which is called the IAM instance profile. Is that okay? Now, we have to create an IAM role that our EC2 instances that will be created by ElasticBeanstalk will assume, because the application that we are deploying needs to interact with, for example, secret manager. It needs to interact with parameter store. It needs to interact with our RDS. It needs to interact with some other systems, right? Because the RDS database that we're going to be creating this time around is also going to be generating its own password. And of course, it's going to be storing that into secrets manager. All right, we are not going to be assigning any password to the database. The database will generate its own password and store that into secret manager. And in order for our application, all right, to be able to fetch that password and basically use that to authenticate with the database and then store our data data into the database, you need to create an IAM role or an instance profile that your EC2 instance will assume that will allow your EC2 instance to be able to fetch, all right, the secrets, all right, from the secret manager, and then your application code can use that, all right, to talk to the database. Is that okay? So that is why we have the instance profile right here. And then of course, some other parameters like the DBOs, the DB username, and the DB, all right, name are stored inside of the parameter store. So because if you look at what we have here, we're still using parameter store. All right, the secret manager is basically to help us to manage our database password. All right, but parameter store is still being used to manage some other non-sensitive parameters. All right, like the database host, database username, and the DB, all right, name. So that's why we're using parameter store. So we're using both this time around. Now, one of the things that we have also done here is that we have the ElasticBeanstalk environment variable. And so in this namespace, we are basically telling ElasticBeanstalk that we want to save, all right, or populate the ElasticBeanstalk environment with some environment variable that our application can use. So instead of creating in this code base, instead of creating a .env file that would help us to handle all of those variables and all of that, we are leveraging the environment variable section of ElasticBeanstalk to store all of these details. That means our application code will have to be reworked to fetch its variable, all right, or the value of the variable that we define in the code from the ElasticBeanstalk environment, right? Because in this case, we are no longer using the .env file, which is to define our environment variable, but this time around, we are basically leveraging the ElasticBeanstalk environment variable that is already part of our ElasticBeanstalk. So now our application code will have to fetch the value of all of these parameters from the ElasticBeanstalk environment variable. And that is the reason why, of course, this instance profile role is very important. And we're also still going to create a service role for ElasticBeanstalk so that ElasticBeanstalk can help us with all of this. So in whatever it is that we're doing here, you can see that we're not really at coding values right here. So everything is going into parameter store and, all right, a secrets manager. And our application code has also been reworked, all right, to be able to fetch its value from the ElasticBeanstalk environment. And then ElasticBeanstalk will talk to secret manager, talk to parameter store, and then it's going to be able to populate our code with the correct, all right, values. Okay, so all of these things that you see are basically environment variables, right? And if you look at what we have here also, we are also fetching the database, all right, secrets, all right, and then we're storing that variable, all right, the secret ARN, we're storing that also within the ElasticBeanstalk environment so that our application can fetch the value, all right, leveraging that. Is that okay? And of course, we have a bucket also that we're going to be using. All right. Also, because our application requires that whatever it is that our user uploads, it goes into an S3, all right, bucket. So we have that bucket also specified within the ElasticBeanstalk environment. Okay. And then, of course, we have a service role that ElasticBeanstalk is also going to assume. So there's going to be two roles. So one is going to be a service role that the ElasticBeanstalk will assume. And then the other role, which is the instance profile role, is going to be assumed by the instances that will be created by the auto-scaling group, all right, used together with Elastic, all right, Beanstalk. Okay. And then here we are also defining our VPC. So here we say we're using a VPC ID. And then here also we're specifying a namespace of EC2 VPC, basically telling ElasticBeanstalk that our ELB, all right, must use the public subnet that we have defined, and then our EC2 will use the private subnet because we do not want to expose our instances to the public. All right, so they're going to be launched in the private subnet because in that gateway and other things have been configured for them. But the load balancer, because it is public facing, has to be deployed in the public subnet. All right, and that is exactly what we're doing here. And of course, for the EC2 instances also, we do not want them to have any kind of public IP address. So that is turned to what? To false, which means our EC2 instance will not have any form of public, all right, address. It's going to be just private. Okay. And then, of course, for the ELB, we are also basically telling ElasticBeanstalk with the settings that the ELB scheme is going to be public because you know that your load balancer can either be internal facing or it can be internet facing. So in this case, we want it to be internet facing. So it's going to be a public, all right, load balancer, not a private, all right, load balancer. And of course, here we're specifying our instance type, all right, the minimum instance, the maximum instance, and of course, we're specifying the instance that our, all right, EC2 will use. And then of course, the security group that our load balancer will use. And then of course, the security group that our instances will also use. And also, we are also defining what you call a deployment policy. Okay, so here we want to have a rolling deployment policy, because if you want to update our ElasticBeanstalk application, we do not want to have any outage. So instead of using the rolling policy, instead of using the deployment policy of all at once, we're using rolling. And then rolling basically means it's not going to update all at once, all right, but of course we have to define a percentage. So here we're saying it's going to be batch size, which means it's going to be in percentage, and the batch size is going to be 50. So that means if we have two EC2 instances that we are running, and then there's going to be an update, all right, on that application, it means that it's going to be updated one at a time, right? Which means one instance is going to be live, so that our end users can actually access that while the other one is being updated. And as soon as the first one is updated, it attaches that back to the load balancer, and then the second one also, is degraded, and then a new update happens, and then the second one is also added back, to the load balancer. So the purpose of that is that we want to ensure that we do not have any outage whatsoever. And so that's why we're using a rolling update, not all at once. Okay, because all at once means all the two instances will be downgraded at the same time, and then there's going to be outage until, ElasticBeanstalk finishes with whatever it is that it is doing. Okay, so we set all of that as well. And then, of course, we also have to put some rolling update policy in place that the minimum instance that should be in service, is 1. So which means regardless of whatever it is you're updating, even if you have 3 instances, at least one of them must still, be in service while the update is going on. Okay, and then we have all these other things, that you have right there. So those are some of the settings that we have to set up in order for us to use ElasticBeanstalk. So all of these settings apply to ElasticBeanstalk, and this is, what we're going to use to create our ElasticBeanstalk. And then for the output, we're basically outputting some things like the ElasticBeanstalk environment name, the URL, and of course the ElasticBeanstalk CNAME, so that, by the time all those resources are created, we want to basically grab the URL and just go to the browser and, access our ElasticBeanstalk environment, and then be able to interact with our application. Is that okay? And then of course we have some variables right here. Some we have defined values for them, and some we do not have any values defined for them right here. And then there are some of these that are deriving their values from the TFS, and some of them will be getting their values from other from other modules that will be outputting some kind of values and all of that. Is that okay? So that is what we have right here. Now, of course, we have some IAM roles that we have, created. If you look at it here, also we have the AWS IAM role. We have the policy, assume role, ElasticBeanstalk, and then we have some, policy or roles that we have also, that we're also creating. This one is for the EC2. This one is for the ElasticBeanstalk service itself. And then we have for the EC2, and of course that's going to assume the role. And right here we have some policies that we are attaching, to them. For example, we're using the ElasticBeanstalk, service, and then ElasticBeanstalk web tier, because the tier that we're deploying is the web tier, not the worker tier. So we don't need any policy that relates to the worker tier, but the web tier. And right here we're defining some policies, so that our EC2 instance should be able to, get parameter from the SSM, and of course get the secret value, leveraging the secret manager, policy, and then all of that. Okay, so we have all of these defined. We talked about some of these in the last video. Okay, so that's for the IAM. For the network, of course, we are basically leveraging the same network we used in the last video, creating an internet gateway or NAT gateway, having 2 subnets in 2 different AZs, and all of that. So this is the same network configuration that we used in the last video that we uploaded. And then for the RDS, we have that defined also. So we have the identifier, the storage is going to be using GP2, the engine is going to be my SQL, all right, the engine version, the engine class, all of those ones are using a variable, all right, and then here we say master, all right, manage master user password equals to true. So what that basically would do is that instead of, us assigning a password here, all right, RDS is going to create a password by itself and store that, all right, in secret manager, okay, and then we're going to fetch this, the password from the secret manager so that our application can use that. And that is already the secret ARN that we are storing inside of the ElasticBeanstalk environment. Okay. So, and then of course we have a security group defined here for the RDS. We can actually copy this out to the security group configuration here, but I just left it right here. All right, for us. So, I mean, this is a security group allowing 33. But if you look at what we have here, all right, it is only allowing access on the 3306 port, all right, from the security group of the ElasticBeanstalk, auto-scaling group. All right, so it is only our instances that can access, all right, these database on this port number. Any other access will be denied. Is that okay? And then we have all of this. Now here also we have the SSM parameters that we are creating. So instead of putting those values inside of the .env that I mentioned earlier, we're basically using, all right, Terraform to create, all right, the parameter store automatically. Is that okay? We're using that to create a parameter store automatically. So here we're specifying the parameter store path, and then the type is string, all right, and the value for these will be generated from the database. So by the time the database gets created, the endpoint, right, will be generated, and then that will be stored inside of these parameter. And then we have a lifecycle rule here from Terraform, which basically means, if we want to update this parameter store, the value, all right, should not be changed, which means it should ignore changes to the value. All right, so the value will not be changed. So that's what that means. And then the database name also, that one is getting its value from the DB name. So we are passing that in from the Terraform.ta verse. And of course, we have the DB username, which is also getting its value from the Terraform.ta verse, right? But of course, the database endpoint will be sourced from the RDS when it's created. The password is going to be sourced, all right, from the secrets manager. So that's for the RDS. And then for S3 also, we have two buckets that we are creating. One bucket is basically going to be for deployment, because our application code is going to be zipped and then copied to an S3 bucket, and that S3 bucket is what we're going to use to deploy to our ElasticBeanstalk environment. So the other bucket, which is uploads, it's basically going to be the one that our application would use, so that anybody that uploads anything, all right, to the application, it's going to go into this uploads bucket. Is that okay? So we have that created also. So the deployment bucket is basically to package our application into a zip file and then or copy that into this bucket, and then that is the bucket that ElasticBeanstalk will use to deploy, all right, the application. And then we have some configuration right here to block public access. These are best practices that we have to follow, because your bucket should not be publicly accessible and all of that. And of course, you have to configure some, IAM policies and all of that to specify what services and who, all right, can access, all right, your bucket. All right, so we have some policies right here that we have, all right, that we are defining, okay, as to, how the bucket can be accessed. So that's for the S3. And then for security group also, all right, we have some security group defined right here. So here we have, the ALB security group defined. The ALB security group, should allow traffic from anywhere on port 80 and 443. Okay, and then of course we have the EC2 security group as well, which would allow access, all right, on port 80 from the security group, all right, of the load balancer alone. Is that okay? So that's what we have right there as well. And then we also have a security group for the database, right? Now, this is a duplicate right here. So I think we need to correct that, all right? So these are duplicates right here. So that means the one that I have here, I didn't even notice, right? So that means we can safely remove, all right, the one we have here, but that means we have to check this variable, all right, this EB security group ID. We have to check that, okay, in order for us not to run into any kind of error. Because right here for the security group, we already see that we have a security group created for the RDS, and that is already allowing access, all right, from the instance security group. All right, so that's already allowing access from the instance security group. So we can actually just, remove this one. So which means we don't need this one right here. All right, so we can actually remove this. Okay, so that is not needed. And so what we can also do is that this particular variable is not also needed. So we can remove that also. And then right here, it's what we need. So we already specified the correct security group. Okay, so that means in the root module of the RDS, we need to make, some adjustments as well. Is that okay? So we have that defined right here. Okay, so that is for the security group, the S3, and all of that. So let's take a look at the main.tf. So for the main.tf, like I told us in the last video, you're basically calling, the child module in the main.tf. So the S3 module, you call it out, and all of the things that you have here are basically variables that you have used, all right, in that, child module that you need to now assign values to, right? Like I told us, there are some variables that are going to source their own value from the TF, so which are the values that we supply. But there are variables that are going to get their values from, other modules, the output of other modules. So in this case, the bucket name is going to get its own value from, variables that we have defined. For example, the project name is what we define, the environment variable is what we defined, and all of that. But all of these variables that we have defined, we need to now assign values, to them. Okay, so we need to specify them out here. And of course, for the network also is also the same thing. So the source is going to be ./modules, basically referencing this folder, and then the name of the module, which is network, that we have right here. And of course, the project name, the environment, the VPC CIDR, the default route, all of these are variables that we have used, in the child module, and then we're now basically passing values, to them. And for the RDS, we have these RDS right here. And then we have all of these variables also. Like I told us, this right here is no longer, needed, so we can remove that. We can remove that already. Okay, we can just do away with that. But of course, we can do away with that, But then let's take a look at the main.tf again so that we can see. So here we have VPC security group ID. So where is it getting its security group? Where is it getting it from? So here it's saying AWS _ security group, .rds.id. That is where it's getting a security group, from. But if you look at what we have here in the security group section under the main.tf, the name of the security group is actually AWS _ security _ group, RDS. But that is also what we have, okay? But then this is referencing a resource that is created within, the module. But the security group, it's another module on its own, So that means what we have here, it's not going to work because this AWS _ security group is not created within this module. It's actually an external module. So what we can do here is to basically just say var, so we can basically just say RDS, _ security group, So we can just say var RDS security group. Let's just call it that. And so what we're going to now do is to now copy this, and then come here to variables, for the RDS, and then come here, and then we're going to create a variable, and then the name of the variable is going to be this, and then we can just use, Copilot to do that auto completion, okay? So now, what we are going to now do now is that we're going to come back here. Already in our security group, we already have an output for the RDS security group right here, this one right here. So what we're now going to do is that we're going to go back to the main, and right here, we're going to come here, and then we're going to give, the RDS a name. So here, I'm going to call this RDS security group, and then the module, is going to be module.security. So calling my security module dot, the output. So there are three outputs that my security module is generating. So there's the ALB security, there's the instance security, and then there's the RDS security. So the one we're going to be using is the RDS security. So that's what we're going to be leveraging. Okay. So we need to make that correction, because if you leave it like, what it was before, then there's going to be an issue, okay, with that. But now we've made, the necessary correction. Is that okay? So we've made all the necessary correction that we are supposed to make. Okay, so now we're good. Now for the IAM also, we have, all right, all of these variables, and then we have values assigned to them. The account ID is being sourced from the caller identity. We're basically using the data block to get that. The region is also gotten from the TFS. Right here, our region is, so let me change this to US East 1. All right, let me change that. Okay, so US East 1, and then I think all other things will remain. All right, so the region is being sourced from that. So this is the region variable, and then the value is being assigned right here. Okay, so the region has been sourced from that, and then the app name has been sourced from the project name. The S3 policy ARN is being sourced from the module, the S3 policy itself, and all of that. And then the ElasticBeanstalk. All right, so these are all of the variables that we have defined inside of the ElasticBeanstalk child module. And right here, what we're basically doing is that we're listing out the variables, and then we are passing in, all right, values to them. It's like pointing the variables to where those variables should get their values, all right, from. And that's exactly what we're doing, all right here. So the app name is getting its value from project name. App description has been coded here, but of course we can use variable for that as well. I mean, you know that by now. The environment name has been gotten from the variable. The VPC ID has been gotten from the network module. The subnet ID is also being sourced from the network module. The instance type has been, all right, sourced from the TFS, because here we have, all right, you know, the instance, EB instance type, minimum and maximum. So we have all of that defined right there. And then the minimum, the ALB security group is also being sourced, all right, from the security group module. The instance profile is being also sourced from the IAM module. All right, the instance security group is also being sourced from the security group module. The public and the private subnet IDs are being sourced, all right, from the network module, all right, as well. And then, of course, we have the region, we have the account ID, we have the tag, we have the service role, the bucket, and all of that. And then you can see where all of these values are being sourced from. And also we have the security, all right, I mean, all the variables, and then where they get the values from also specified. And then we have the local, which is basically used to specify, all right, some environment, all right, parameters. Okay, so that is the Terraform configuration that we're going to be using to deploy our ElasticBeanstalk. But now we are not deploying on our local environment, because I mean, we want to follow best practice that we do in an organization, right? Because I mean, when you work in an organization, you're not going to be deploying Terraform locally, you know, within your VS Code. You're going to be leveraging, all right, a CI/CD pipeline, right, or what you can call a GitOps practice. Okay, so we're going to be using GitLab. Of course, you can use GitHub Actions. All right, we have a video on that on the channel, so you can watch that as well. But in our own case today, we're going to be using GitLab, all right, CI/CD. So we're going to be using that to deploy our Terraform configuration, and of course, we're going to be using that to package our application and then deploy that to the ElasticBeanstalk environment as well. So now let me walk you through what we have, all right, for the CI/CD, all right, configuration. So let me just collapse all of these, and then let me bring this down a bit. All right, now if you look at the CI/CD configuration, I am using an image that I have created. All right, I had to create an image that I can use, and that image is also available, all right, on Docker Hub. It's a publicly available image that you can use. So I had to create an image that has some tools that I use regularly, and I believe it is something you can also leverage in your own pipeline as well, right? So the tool, the image contains the AWS CLI, it contains the kubectl for Kubernetes, and it also contains Terraform and some other tools like your Zip, JQ, and some other things like that. I mean, that image bundles everything, and then it's built on the Alpine, all right, image, okay, which is basically lightweight. All right, so I'm using my own Docker image, all right, to basically use to run my pipeline, because as you must know by now, if you have gone through my GitLab CICD series, which I'm going to link, all right, somewhere here, you realize that when you're building with GitLab or even GitHub Actions, your job is actually run inside of a container. All right, so that means you need an image to run your jobs and all of that. Now, another thing that we have here is that we have different stages. So the first thing we're going to do is that we're going to create a DynamoDB table that, you know, Terraform is going to use to lock, all right, our state, so that anytime we're doing Terraform apply, the state is locked down, so that anybody that is trying to do anything at that particular time when we are doing some apply, then it will tell them that the state has been locked and is in use by, other people and all of that, so that, there will not be any conflict of apply or plan and all of those kind of things. So we're going to create a DynamoDB table that we're going to use in the Terraform backend, all right, to basically lock sessions of the state file. And then we have the init, which will initialize the Terraform configuration. We also have the validate block, which will also perform some validation on our Terraform code to ensure that, syntactically and semantically, our Terraform configuration is correct and it follows, all right, the Terraform structure and best practices. Okay. And then we have the Terraform plan that will basically do the plan and tell us the number of resources that we created and, all the other attributes and all of that. And then after that, we have the Terraform apply, which basically would take the plan that have been generated and use that to create our infrastructure. And then we have the build, all right, stage that will basically take the code that we have and build it, all right, into a zip file, and then copy that into the S3 bucket that ElasticBeanstalk will fetch from to deploy our application. And then after that, we have the deploy stage, which is basically to deploy the zip file, all right, to ElasticBeanstalk environment. And lastly, we have the destroy stage, which basically is to destroy all of the architecture when we are done, all right, with whatever it is that we are doing. Now, another thing that we have here is that we have the variables. Now we have the project name and the environment, and these variables, we have to save them also inside of our GitLab CI, all right, CD environment as well. So we have the project name and we have the environment. Now remember, if you take a look at your Terraform TFS, the project name is, I just give it dev PHP app and then dev accounts just to give it that. But then your GitLab CI must also have, those, because in the pipeline somewhere we referenced, all right, those environment variable. And then of course, Terraform must be able to help us, all right, we're using TFVAS, all right, underscore project name, because we don't want any kind of disparity when it comes to the project name and the environment name. All right, so the same name that our GitLab CI will use as the project name and environment name, we want it to be similar, all right, to what our Terraform is also using. So that is why we have, all right, something like this. And in the pipeline section, all right, if you come here to settings, to your CI/CD settings, you're going to come here to variables, and you can see that we have defined the same thing right here: the project name, the environment name, and of course we have our role ARN, and then we have our default region, all right, created automatically right here. The role ARN is basically because we are leveraging the GitLab OICD or OIDC, which means we don't have any secret key or access key created. We're basically leveraging, all right, the open ID, all right, connect. That's what we're leveraging. So what that would do is that GitLab is going to obtain is, a token from AWS, and it will use that token to basically execute Terraform configuration and create an infrastructure. So instead of coding your secret or access key, those are long-lived tokens. But what we need is just a short token that we can use for a certain amount of time, and after the job is executed, the token basically just expires. All right, so that is what we're using. So we're using GitLab OIDC. I have a video on that already that on the platform where I showed you how you can create your identity provider on AWS and then use GitLab to connect your AWS and get short-lived token without your access key and your secret key. And another thing that we have improved upon in this video is that we have abstracted all of that token generation, all of that step. We have abstracted it out into an hidden job. Okay, and so here we have dot default underscore setup, and then we are passing it a name of I've forgotten this thing now, but of course the name here is token, right? But behind that token we have what you call is it an ampersand or something that we have there? All right, and then of course the dot basically means that this is going to be an hidden job. So what that means is that GitLab is not going to see that job. It's not going to see it as a job that it should execute. So basically we're going to be using all of this. Now here we have abstracted out all of that token generation stuff. So instead of repeating, all right, instead of repeating all of these things for each job, we basically have created, all right, a default job that is hidden to GitLab, all right, and then we can extend, all right, for other jobs. Is that okay? Right, so here we have the state lock, which is basically creating the DynamoDB, and this is how we are basically leveraging that hidden job. So for this particular stage, it's going to get its own token, all right, using that job. So, but the difference now is that instead of repeating all of these things, right, in the before script section of this job, we're basically, all right, use an hidden job for that, and then we're giving it a name. So all we have to do here is to use the symbol, all right, this YAML symbol, to basically reference that name. All right, so what that means is that this stage is going to, first of all, obtain the token using all of the configuration that we have up there, and then use that to run, all right, whatever it is that we want to run, all right, on the platform. Okay, so that is another improvement that we have made from the last video. All right, and then here also we are setting up our region by default. So basically we're telling GitLab that our region is what? US is to 1. So we're setting that in the pipeline automatically as well. So this stage is going to create a DynamoDB table for us. I mean, we saw that in the last video as well. And then the init phase, you can see that we're referencing that token. But the difference now is that, I mean, our jobs are now, all right, I mean, doesn't contain too much thing. It's clearer now. We can see exactly the things that we're executing and all of that. So we don't have to repeat, all right, all of that, token commands, right, for every job. So basically abstracted that. All we need to do is just to reference that name that we're giving to it. And then it makes it a lot easier and it makes our job, all right, cleaner. So here we have the Terraform init, which would, of course, initialize the Terraform configuration and do its own thing. And then we have the validate. So here we're doing validation. So we're doing the Terraform format. So basically what we have here is that it's going to check if our Terraform actually conforms to the Terraform format. Now, the check means that if the Terraform configuration does not conform to the Terraform format, then the pipeline is going to fail. All right, that's why we have the check right there. Okay, so the check basically means check if the Terraform configuration conforms to the Terraform structure. If it does not conform to the Terraform structure, tell us, all right, the Terraform files that do not conform to that structure, but the pipeline is still going to fail regardless. All right, and then the next thing after that is to validate. So validate the configuration. All right, are there any kind of maybe circular dependency? Are there things that are not properly configured? Is there any module that you're referencing that you've not defined? All those kind of things. Those are the things that validate. All right, we'll check. And then the next thing, of course, we have to do Terraform plan. All right, of course, we're generating a plan. And then, of course, we are saving that plan as an artifact so that the apply job can basically use that plan to create our infrastructure. All right. And then for the apply job, we also have that. But of course, the only difference is that we are triggering that manually. All right. So that's what we're doing right here. All right. So we have the Terraform apply. The input is false because we already have a plan that we have generated, and it is that plan that we want to execute. So we don't have to do auto approve. All we need to do is just to pass in the plan that the Terraform plan has generated. Now, the next thing here is that we are building our application, all right, into a zip file. So we need the zip command to be available. So like I said, the image that I have already has zip bundled with it, so I don't have to use another image that has zip, or I don't have to start doing apk add, no catch, all those kind of things. All right, so here we're basically doing cd, all right, into this app folder right here. So we're cding into this app folder, and then we're running the zip command, and then we're generating what you call applications.zip. So we're generating that application.zip inside of the main directory. So we're not generating it inside of the app, all right, directory. So that's basically what we have right here. Okay, so we have the application.zip, and then so we have the dots. So the dot basically means that everything that is inside of that app folder is what we want to zip up, all right, as application.zip. So that's what the dot signifies. And then, of course, we are also having that as an artifact as well, because we need to have it as an artifact so that the deploy stage can take that, all right, artifact and copy that to the S3 bucket, all right, that Terraform must have created, all right, for us. So here we have the build phase, and we say this needs the build phase, which means the zip must have been completed before you even attempt to copy what has been zipped, all right, into S3. Okay, so we have AWS S3 CP application.zip, all right, and then we're saying S3, so the project name, the deployment, that's the full path, all right, of the S3 bucket. Remember, this is how we created the S3 bucket, so we're basically leveraging that, and that was why we need the TF-VAS, all right, that we needed earlier. And so right here, after that, We also create an ElasticBeanstalk application version. So we specify the region, the application name, the version label. Now, all of these commands are AWS CLI commands. Okay. So when you go to the CLI command reference, you can actually get all of these things, all right, from there. All right. I mean, in one of the videos, I think the last one also, I showed us how you can go to the AWS CLI command line reference, all right, to get how to use the AWS CLI command. So all of these AWS S3 copy command, these are, all right, CLI commands that we are using inside of the pipeline. All right. And that also means that the image that we are using also has the AWS CLI already bundled with it. Because if the image doesn't have AWS CLI inside of it, then these commands will not run. All right. So all these are AWS CLI, all right, commands. And right here, we are also updating. So after we have created an application version, we now would update, all right, the ElasticBeanstalk environment with, all right, the new application, all right, version. Because part of the new application version that we have, we already specified the bundle, and we are telling ElasticBeanstalk that the file is actually inside of an S3 bucket, all right. And then the S3 bucket is the name of the bucket, and then the key, which is basically the object that you're looking for, is application.zip. So that's what we have told ElasticBeanstalk. So once that is established, then we can update the ElasticBeanstalk environment. Because remember, when you create ElasticBeanstalk, it comes with a default environment, a default landing page. All right, but you can override that default landing page by uploading your own code, all right, into that environment. So that's what we have done here. And then we're updating that environment and, doing that. And the last part here is to ensure, because what we already have from the Terraform configuration is that we want to use the rolling update. So what we are saying here with this command is that this job is not going to be marked successful until the ElasticBeanstalk has been, the configuration change, the update has been completed. All right, that is what we have here. So the command is AWS ElasticBeanstalk wait environment updated, which means the job is going to be marked complete when the ElasticBeanstalk environment is become okay or stable, right? That is when this job will be marked what? As succeeded. Okay, because we don't just want to deploy or update the environment and then the pipeline says passed, right? We want to wait until that environment returns, all right, a signal to the pipeline to say, well, the status now is okay. That is when the pipeline can be marked as what? As passed. So that is exactly what we have with this last part of the configuration. Okay, and then the last one, of course, is the Terraform destroy, which basically is to destroy, all right, the whole environment. So that is what we have right there. So we don't need this dependency, so we can remove that. All right, we can remove that from here. So we don't need that. Okay, so that is the last part, all right, of the configuration. So the next thing we need to do now is basically to go ahead, all right, and push these changes to the repository, all right, and then allow GitLab CICD to basically build out, all right, infrastructure for us, deploy the application for us. And all we have to do is to go to the GitLab CICD environment and then, fetch, the URL, access our application, and we're good, all right, to go. So that is what we want to do right about now. Okay, another thing that I want to point your attention to is that you can see from here that I've also specified a tag, which means I am using my own, all right, GitLab runner. Okay, I have an EC2 instance that I've hosted on AWS. If I show you that, all right, and if I come here to my EC2, all right, I have my own runner that I have created on AWS, and I think it's actually in this London region. All right, and if I go to instances, I can see that I have my GitLab runner executed. Now, if you don't know what a GitLab runner is, I encourage you to go through my GitLab CICD series. I'm going to be putting the link in the description so you can watch that and understand what a runner is. A runner, basically, in summary, it's where GitLab actually executes your job. So all of that job that we have defined inside of the pipeline right here will actually be executed on that server. That is what a runner is, right? You can see it as a node where your job runs. Is that okay? So, like I said, the next thing now is to basically push, all right, all of these changes. So I'm just going to say git add, all right, git commit, okay, and then git -m, and then I can just say, so I can call these elastic, all right, beanstalk. Okay, and then I can do git push. Okay, and because I have my GitLab workflow installed, GitLab workflow extension installed inside of my Visual Studio Code, I can actually visualize my pipeline also right here. Okay, if I refresh here and I click here, I can also see, all right, my pipeline here. You can see that it's using my image, and then of course it's going to pull that, and then it's going to run, all right, all of the stuff. Okay, so I'm going to pause my screen here, and then I'll come back when we have all of these things, all right, deployed and sorted out. All right, so stay tuned. I'll be right back. Now, if you take a look at what you have here, it tells us that the Terraform FMT check, it says, the job failed. And that is because the main.tf, remember we made some modifications, right? And so we didn't do that, on our own side, right? And of course that failed the pipeline. So what we're supposed to do after you make any change, right, to your Terraform configuration, the first thing you would do is to say Terraform FMT, and then you say recursive. All right, recursive basically means that it's going to go all right into other folders, right? If there are other folders like the modus folder, it's going to go there, look at all the files, and apply the canonical style of Terraform to all of those configurations. So if I press enter, it tells me that my main.tf has now all right been modified. It follows the Terraform canonical style. Okay, so now I can do Terraform all right, validate also to check, so that I will not fail the pipeline again. All right, now you can see that. Now, if we didn't do Terraform validate, that will have happened in, all right, in the pipeline, and that would also have failed, all right, the pipeline. So now that I did Terraform validate, it's telling us that the managed resource AWS_RDS has not been declared, all right, in modules.rds, right? It has not been declared, all right, in modules.rds. So let's see that, right? So then that is the modules rds output.tf line 13. All right, so okay, so let's go to rds, all right, and then output, right? So output. And so it's telling us that we have something that has not been defined. Okay, so secret ARN. So we have AWS_secret_group.rds.id. And it tells us that that is inside of RDS, all right, output.tf on line 13, right? So line 13. So this is what it is referring to, right? So you can see that this is grayed out, right? It doesn't apply. It doesn't really make sense to us here. And really, we don't need this output here because the RDS is not what is giving us the security group configuration again. Remember, we moved the security group configuration away from the RDS into, all right, the security folder, which is right here. Okay, so that means this guy is not actually needed here. Okay, so we don't need it here. So we can actually just remove that. Okay, because we don't need it at that point anymore. Okay, so now I can clear my screen. All right, and then do my Terraform FMT recursive again, just in case, and then do my Terraform validate now to see if, all right, my configuration is valid. So now my configuration is valid. Now, if we have not done this locally, then the pipeline will have also failed. But now we are sure that if we push now into the pipeline, then there shouldn't be any kind of failure. Everything should go, all right, as planned. So now I'm going to do git commit -am. All right, I'm just going to say Terraform, all right, validate. Okay, let's just put validate. Okay, and then I'll just say push. All right, and then I'll push into the pipeline. And of course, the pipeline is going to start all over again. So I can refresh from here, and you can see that the pipeline has started again. So we'll wait again, and let's see if we have any error. We come back, we fix it until we're able to deploy our application, all right, completely. Okay, so I'm going to pause again here and then come back when we have these things sorted out. All right, welcome back, guys. You can see that our pipeline executed successfully. Okay, we started from this stage, which is the state lock. All right, and then we can see here that it told us that the table already exists. All right, even in that region. Okay, so that means we already have a table by that name in the US East 1 region. So it didn't bother to create a table because it's already available. And then our Terraform init also executed successfully. Okay, and if you look at what we have here, all right, it initialized all of the modules that we have. And then it also downloaded the plugin. And if you look at what we have here, we're using the latest, all right, version of the Terraform AWS plugin, which is the 5.84.0. Okay, and then of course it told us that the Terraform was successfully initialized and S3 is being used as the backend. Okay, and of course, I mean, it saved some artifact for us based on our pipeline configuration. Now, if you move on to validate, now initially the previous pipeline failed at the validation point, but then we were able to correct that. And now we can see that the Terraform validate says everything is fine and the job also succeeded. Now, on the plan side, of course, you have to run Terraform plan. So that would run through our desired state, which is the Terraform configuration that we have defined. And then it will run through all of that and then tell us the number of resources that will be created. So if I scroll down here, all right, it tells us that 40 resources will be added. Of course, it's not changing anything. It's not destroying anything because we are just creating these resources. And these are the outputs that we're going to get at the end of, the creation of these resources. So the CNAME, the bucket name, the ElasticBeanstalk environment, the RDS endpoint, all of these things are going to be visible to us after these resources have been created. All right. And then after the plan showed up, all right, of course, we have to trigger the apply manually, which we did. And so for the apply section also, it basically will take the plan. So excuse me. Now, what the apply would do is that it's going to take the plan that we have, generated and stored as an artifact. Because if you look at what you have here, it says downloading artifact, all right, from init, and then downloading artifact for plan. So it's basically going to take that artifact and then use that to create the resources. Because if you look at this output, Terraform apply is not refreshing. It's not going through, all right, the Terraform configuration again to now ask us whether to approve or to, do whatever. So it's basically just taking that plan and then applying whatever the plan has generated and then using that to create, all right, our resources. So that is basically what Terraform is doing. And so if you scroll down also, you can see here that, everything was generated automatically. It created everything, the RDS, the networking, the database, the ElasticBeanstalk environment was created. All right. And then, of course, it told us here that 40 resources have been added. And then we can see all of the outputs. So this right here is the endpoint of our ElasticBeanstalk. So I can actually copy this. All right. And then if I pull that on my browser, I will be able to access my ElasticBeanstalk environment. All right. And then we went to build. So the build phase is basically to package the application code as a zip file and copy that, all right, to S3. And that is exactly what we have done. So if you look at what we have here, we are seeding into the app folder, and then we are running the zip command. And then, of course, it zips all of that. And we're also generating an artifact because the next stage, we want to take that zip file and copy that, all right, to S3, all right, bucket. And then here we have the deploy phase. So at the deploy phase also, okay, you can see here that, of course, the first command that ran was the upload command. So right here, we are uploading, all right, from the artifact to the S3 bucket. And you can see the S3 bucket right here. And the name of what we're uploading is what? Application.zip. All right. And right here, we are also creating a new version, all right, of the ElasticBeanstalk application. And now we are telling ElasticBeanstalk that this is the bucket that contains the code that you want to deploy, and the name of the object in the bucket is what? Application.zip. And then we can see that after we have created a new application version, all right, then of course the environment was to be updated as well with the new stuff. And then we can see the status here telling us updating. And then after the ElasticBeanstalk environment has given the GitLab pipeline a stable signal, then it told us here that the job, all right, succeeded. So that means right now, if I go here to my browser, all right, and I paste in the URL that I copied from the pipeline, and I paste that in, then I should be able to access my application if everything is fine. All right. If there are no issues whatsoever, I should be able to see, all right, the application that I've packaged and deployed to ElasticBeanstalk. All right. So right here now, I can put in the name. So I can say my name is Shell. All right. And then the email address is email@Shell. This is just more like a contact us form, all right, just to practice. And then right here, I can say, I am inquiring, all right, about the DevOps bootcamp. Okay. Let's say that's the message. All right, and then I can come here and say upload. So let's say you want to upload your CV or a document. Let's say that's part of the requirement. And then I can come in and upload that, and I can click on submit. And if everything is fine, like I said, what we should see is that the message sent successfully. So that means this upload that I've done has gone into my S3 bucket. So the administrators can go into the S3 bucket and download all of these CVs and applications and all of that. And then all of these entries also have been stored in my database. Because if my application was not able to fetch the database secrets, right, then I will get an error message. Okay, but now it tells me message sent successfully. So that means, all right, everything was sent, right? The database was populated. The S3 bucket also, all right, got the file uploaded into it. Because now if I go to the S3, remember we can't access our RDS because it's not public, right? So, and then if I go to the bucket, so the bucket that we're using right here is this should be the deployment account or uploads, right? This one, right? And then if I open that bucket up, this is the bucket that we created with the Terraform. And if I click on upload, I should be able to see, all right, the file that I uploaded. And of course, if you look at the date, today is 26th of January. So, and if you look at the time, it's something that we just did right now. So it's not something that has been there. So it's something that just happened. Okay, so I can see that the file was uploaded and all of that. So the beauty of all of this is that we have not gone to the console to do anything. So ElasticBeanstalk was created with Terraform. The application was packaged as a zip folder and pushed into S3. All right, and then ElasticBeanstalk environment was updated. All right, from the GitLab CICD pipeline, and we didn't have to go to the console for anything. Even authenticating with AWS was done automatically. All right, using the GitLab OIDC. So we obtained a temporary token from AWS, and that is what we use to deploy. All right, our environment. So